So when you make a graph, you want to go to Insert. We're going to make a scattergram. So go to Scatter. Just this basic dot scatter will work. Go ahead and click on that. And then it's going to give you options to select data. So you want to select your data. Click on this little select range box. Let's replicate the AT graph so we can pick VO2 as our Y starting at minute 3. Go ahead and click enter. Okay, so let's select our Y values. That's going to be VO2. Our Y values will be CO2 and our X will be VO2. You can name the series if you want, but it doesn't really matter. So we'll just click OK, and that'll give us a new chart. So if we kind of scoot this over here so we can have a clean space, you'll notice that it has all these different lines in between. If you just click on those lines, you'll get dots that highlight those lines, and you can hit delete, and that will delete them. You can click on the vertical lines again, and then delete, and that's going to give you a nice clean graph, and that's what you're looking for.
Okay.
If you right-click within the graph, you can change the template, select more data, format the plot area. What we're going to do, if we go back to our chart design and formatting tool at the top, we can add a chart element. So we're going to add an axis title, so primary vertical. That's going to allow you to change the title to liters per minute. And then you want to do the same thing for the x-axis. So axis title, primary horizontal, this is VCO2. So like when I look at the graph, I'm going to look for, do you have all the axes properly labeled? Do you have the units of measure for that axis? And then for the graphs that require r squared, 1 minus r squared, you have that as well. So how do you add a trend line so we can get that r squared data? Just click on any of the data points until most of the data points are highlighted. Right click again and go to add trend line. It's automatically going to set it up for a linear relationship, which is fine for our purposes. So keep it linear. If you display the equation on the chart and display r squared, then you're going to get the initial values you need to complete the analysis portion of the graph. If you're wondering how to extend the trend line past where the data points are set, and this is really important for that anaerobic threshold and RCP, there's this option that says forecast. If you go to forecast, if you look at the units of measure, you try to make it consistent with those units. So we're having liters per minute. So if you choose a forecast for this example about 1, then that will extend the line in both directions. You don't necessarily need it for a basic graph like this, but if you're looking for intersection points for 2 different series, then it's a nice option to have. So once you're done with that, go ahead and X out. We don't need a chart title. You don't really want to have any title because every figure should be able to stand alone with a figure legend. So for figures, the legend goes below the figure. On a table, the legend's above. So for a table, you should have the table title above with any abbreviations included in the table. For a figure, the title goes below. So this would be figure 1 or graph 1. And then you would say this, maybe the graph represents the relationship between VCO2 versus VO2 during a GXC test. Okay. So just some description of what it is. And then you would include your r squared, 1 minus r squared, predictive index, and SEE, and what those are below that. So that's the basics of making a graph. Again, it should look something like this. It shouldn't have any horizontal or vertical lines. You should always have some kind of a trend line and no title within the graph itself that should appear below.